This lecture covers the sun's eastward motion. In addition to its diurnal motion as the Earth rotates, in addition to its north-south seasonal motion over the course of the year, day by day with respect to the background stars, as seen from our vantage point here on the Earth, the sun also moves to the east. Here's the basic idea in which you can understand how that occurs. Okay, so I have my light bulb here, for example, to represent the sun, and then here's the Earth. And let's say that the Earth is positioned here in its orbit. And you happen to be standing over here on the night side of the Earth. You look out in this direction, and you can see the constellations that are there. However, if you're here on the day side of the Earth and you look in this direction, you can't see the constellations of stars that are over here because the sun is too bright, the sun is in the way. However, watch what happens 6 months later. 6 months later, we're on the other side of the sun, and now if you stand here on the night side of the Earth, you could see these constellations here, these constellations of stars, whereas you couldn't see them 6 months earlier because the sun was in the way. And now here, if you're on the day side of the Earth and you then look in this direction, notice that you can no longer see the stars that are here in the background because the sun is in the way. The sun is simply too bright. What this then means is that slowly over the course of the year, the pattern of stars, the constellations that you could see in the night sky slowly changes. This corresponds to an eastward motion of the sun as seen from the surface of the Earth. Now, rather than using the celestial sphere to explain this motion, instead let me just draw out the situation if you can get off the Earth and then just watch what happens as the Earth orbits the sun. From that vantage point, the situation is easy to explain. Okay, so I'm going to draw the following diagram here, and as I do, this is definitely not to scale. Okay, so let's say that right here is the Earth's orbit around the sun. Like so. Let's say that right here is the sun. Okay, now let's say that the Earth happens to be right here in its orbit, like so. And as the Earth orbits the sun, let's assume that it does so in a counterclockwise fashion here on this diagram. In addition to, however, moving on this diagram in terms of its orbital motion about the sun, you of course have to keep in mind also that the Earth rotates. So as the Earth rotates, it also rotates on its axis, and it rotates in the following way. If the Earth is orbiting the sun in a counterclockwise fashion, it's also rotating on its axis like so counterclockwise, such that it ends up doing this, like so, as it orbits the sun. This type of a rotation combined with the orbital motion is referred to, by the way, as prograde. So the Earth then rotates like so in a counterclockwise fashion. Okay, let's say that you happen to be standing right here. If you're standing right here, pretty obviously pointing towards the sun, it corresponds to noon at your location. And then like so, the sun has a position with respect to the distant background stars. And now I'm going to have the Earth move and rotate through one day. So keep in mind that as the Earth is orbiting the sun, it's also rotating on its axis, like so, as it does. Okay, let me exaggerate on the diagram what happens one day later. Let's say the Earth is right here. Okay, now, here in blue, I'm going to talk about this point here on the Earth once again, just as I did up here in the previous day. Notice that if you look off in this direction like so, this line here is parallel to this line. This then means that we're looking off towards the same background stars that we saw earlier. However, notice that this positioning is not noon. It takes the Earth, when it goes from here to here, 23 hours and 56 minutes to rotate in this manner. This type of a rotation is referred to as a sidereal day, and a sidereal day is a rotation with respect to the background stars. Sidereal day is a rotation with respect to the background stars. 23 hours and 56 minutes long. It takes the Earth about 4 more minutes to rotate from this point here to this point here. So it's back to noon again. Here was noon, now here's noon once again, and then we look directly at the sun, for example, like so. This is a rotation of the Earth with respect to the sun. This is called a solar day, and this is what clocks measure. So a solar day is a rotation with respect to the sun. That's 24 hours long. However, notice that we're now looking at the sun against a different background of stars that we saw earlier, 24 hours earlier at the previous noon. So here in red, now looking in this direction, it's a different background. So with respect to our vantage point on the Earth, the sun appears to have moved in this direction like so against the background stars. What direction is that? It's to the east. It's to the east for the following reason. Recall that the Earth rotates like so on this diagram. It's rotating from west to east like so. Showing this direction is towards the east. So with respect to the background stars, the sun has moved against that background, as seen from the surface of the Earth, to the east. If you combine together the north-south seasonal motion of the sun and this daily eastward motion, you then get the path of the sun against the distant background stars. This is also referred to as the ecliptic. It's just very simply the same thing as the plane of the Earth's orbit about the sun. So the word ecliptic refers to basically two things that are essentially the same thing. You have, first of all, the plane of the Earth's orbit about the sun, but from our vantage point on the orbiting Earth, we then see the sun move against the background stars along that path. That path, once again, is referred to as the ecliptic. Now, how can you see the difference between a sidereal day and a solar day? Well, careful observers can see the difference with respect to the stars at night. We don't use the stars to keep track of time. That's a sidereal day. Instead, we use the sun to keep track of time. That's a solar day. So then, for example, if you watch the distant background stars at night, what you will notice if you watch carefully is that the stars rise 4 minutes earlier each day, and then therefore they set 4 minutes earlier each day. So pick an individual star at night and then watch what happens from one night to the next. You will notice that that star rises 4 minutes earlier on the second night than it did on the previous night. That's how you can see the difference between a sidereal day and a solar day. This concludes this lecture on the sun's eastward motion.